A particle of mass m has a potential energy described by the graph shown below. Assume that the mechanical energy is conserved. The particle is released from rest at position r sub 0. So this graph here is actually a graph of position versus, or rather, potential energy versus position. So, and we are asked to solve for, in question 16, to solve for the speed of the particle at position 2RO. Alright, so let's analyze the scenario. The object was released from here, and the velocity of the object at RO is equal to 0. And also, so this tells us that the kinetic energy of the object at this point at RO is also equal to 0, because remember that kinetic energy is 1/2 mv squared. So if the speed of the object is 0, obviously kinetic energy should be 0. And also we know that at RO, the potential energy is equal to 3 UO. So this is the potential energy of the object at position RO. Now we want to know the velocity of the object at 2RO. So this is the velocity that we need to solve for. And we know also that when the object is at 2RO, the potential energy of the object is equal to UO. That's the potential energy. So we would just use the equation of the conservation of energy to solve for this problem. So we say potential energy initial plus kinetic energy initial is equal to potential energy final plus kinetic energy final. So our initial condition would be when the object is at RO. So initially potential energy is 3 UO, and our kinetic energy initial is 0 since the object was at rest. And on the final position, the potential energy is UO plus the kinetic energy, which is 1/2 mvf squared, and and the final velocity is what we need to solve for. So let's manipulate this equation. So we will have, simplifying this, we have 3 UO on the left side of the equation and a U on the right side of the equation. So minus U. Let me just remove these underlines so it doesn't confuse you. And that would give us 2 UO is equal to 1/2 mvf squared. So now I'm gonna multiply both sides by 2. I'll multiply that by 2. So that gives me 4 UO is equal to mvf squared. I'll divide both sides by m. I'll divide that by m. So I will have 4 UOm over m is equal to the square of the final velocity. So I'm gonna get the square root of both sides. So that tells me that our final velocity is equal to the square root of 4 UO over m.